Welcome to Track 4, Advanced. 12 lessons for when one SFT run is not enough. Distillation to shrink a model. Preference tuning to align it. Quantization to compress it. Multitask and curriculum to broaden it. Serving, observability, feedback loop, and tool use to ship and run it. Each technique exists to satisfy one constraint SFT, alone cannot. Beyond a single SFT run. Every technique in this track exists to satisfy one constraint. Smaller and cheaper at near equal quality, distillation. Aligned to preferences, not just correct, preference tuning. Fits a device or serves cheaply, quantization. One model, many tasks, multitask and curriculum. Fast and reliable in production, serving plus observability. Start from the constraint, pick the tool. Distillation. Train a small student to mimic a large teacher. Why mimic instead of more labels? Soft targets carry dark knowledge. The teacher's full distribution shows which wrong answers are plausible, not just the right one. BrewSLM captures distillation offline. Run the teacher across the dataset once, save the top K log probs per position, train the student against that file as many times as you like. Same tokenizer assumption. The KD loss has two terms. Hard label cross-entropy keeps the student anchored to the gold answer. Temperature softened KL divergence pulls the student's distribution toward the teacher's. Temperature softens both distributions so secondary token probabilities, the dark knowledge, become visible. The t-squared factor rescales the KL gradients so they stay balanced against CE. Alpha trades teacher versus truth. Did it work? Quality retained equals student score divided by teacher score on the same eval. 97% retained at 2% of the size is the win. Threshold depends on your constraint. Latency critical accepts more drop than quality critical. The honest comparison is three-way: teacher, plain SFT student, distilled student. Distillation earns its complexity only if the distilled student beats the same size SFT student. Preference tuning. SFT optimizes for one right answer. Preference tuning optimizes for chosen over rejected. Pairs of preferred and dispreferred outputs. DPO, direct preference optimization, derives a loss from the pairs directly, no separate reward model, anchored to a frozen reference. Beta controls how aggressively to move toward the chosen. ORPO folds preference into the SFT loss for a single stage run. Reach for them when better is judgment, not a label. Quantization. Store weights in fewer bits to shrink a model. Q4KM is a 4-bit kquant in the GGUF format, the CPU edge sweet spot. A WQ and GPTQ are post-training methods for GPU inference. GGUF is the llama.cpp format, ONNX is cross-runtime, safetensors is full precision. Method versus format, they are different choices. And always reevaluate after quantizing. The size win is only real if quality holds. Multitask and curriculum. Multitask, train one model on several tasks at once, positive transfer if they share structure, interference if they do not. Balance the mix so a large task does not drown a small one. Curriculum, order data easy to hard. Both are hypotheses, not defaults. A/B them on a fixed gold set and keep the winner. BrewSLM's curriculum harness runs both variants and reports the delta. Serving and inference. vLLM is the high-throughput inference engine. It manages the KV cache, so each generation step only computes the new token, and continuous batching swaps finished requests for new ones to keep the GPU saturated. Latency versus throughput. Bigger batches raise throughput but raise per request latency. Quantized serving compounds the wins. Less memory means bigger KV cache and larger batches fit. Observability and drift. The run event spine emits a row from every stage best effort, wrapped in try-except so a bug in observability cannot break the data path. Drift is what happens when production inputs shift and a static model silently gets worse. The scheduled drift check reruns your gold set against the live endpoint, same gold set that earned the deploy now keeps watching it. When the rate drops, deployment drift detected fires. Capstone C, choosing the right technique. Goals smaller and cheaper at similar quality. Distillation. Goal tone or helpfulness, not one answer. DPO or ORPO. Goal fits a device. Quantize. Goal needs facts. RAG. They compose. Distill the frontier into a small student. Preference tune the student. Quantize to GGUF. Serve efficiently. Watch for drift. The skill is technique selection, then composition. Production feedback loop. Drift detection tells you the model has gotten worse. This lesson supplies the data that fixes it. Log requests and responses at the endpoint, redact PII in flight, sample the boring rows to keep storage honest. Tag bad rows 3 ways manual review, auto tag from drift events, user feedback. Convert tagged and corrected rows into SFT examples. Retrain on a measured cadence. Every retrain reclears the val pack gates. Tool use, also called function calling. Train a small router to emit valid tool calls, JSON, with tool name and arguments. Data shape, tool catalog in the system message, request in the user turn, structured JSON in the assistant turn. Define schemas with Pydantic. The no tool path is training data, not an exception. 10 to 20% negatives teach the model when no tool fits. Evaluate with 2 numbers, valid tool call rate plus argument match accuracy. Prefer parse failures to wrong calls. That ends the BrewSLM Academy. From what a model is to a production fine-tune you can ship, watch, and retrain. You have the whole toolkit now. Pick a project, ship it, watch it, retrain it. The Academy ends here. Your real fine-tunes start now. Claim your completion certificate.